Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey, everybody. Welcome to Math Night. Thank you so much, Dr. A, for that great introduction. He is absolutely right. If you want these slides, you can text MathStream1 to the phone number that you see on this screen, and we will absolutely make sure that you get a PDF of the math problems that you see today. For those of you who have been with us for a few weeks now, the math problems from this week are a lot of the problems we just didn't get to finish the last couple of weeks. So you may recognize them if you've gotten the slides from weeks before, but I felt it really important for us to be able to solve them together anyways. So if you haven't been with us, you get 10 problems, which is awesome. I usually try to get through about 10 problems every week, but sometimes we just don't get through 10 because we're really talking through and explaining those problems. The first thing I want us to do before we get started is let me know where you're from. Comment in the comment section and let me know what exam you're prepping for and where you are from, as that will help me really guide our discussion today as we go through these problems. As Dr. A said, if you have any questions at all throughout the event tonight, please don't hesitate to drop them in the comment box. Last week, a lot of people were asking questions and interacting, and it really just helped us guide our conversation. So if you have any questions, don't hesitate to ask in the comment box, and I'll be glad to answer them as I'm sharing with you guys tonight. So without further ado, let's go ahead and get started. I'll introduce you to myself and where I'm from. I'm from Central Florida. I'm about 40 minutes north of Disney. And I love math, if you can't tell. We do have a really big dog. He is like 160-pound Great Dane. Sometimes he barks at the squirrels. Sometimes he makes a cameo. So if you see him, you can say hi. Hello, we are prepping for math 4 through 8 and math 7 through 12. Fantastic. There's going to be plenty of problems for you tonight. So let's go ahead and get started with our first problem. I'm going to read the problem aloud, and then we're going to walk through how to solve it. Welcome. I see quite a few people here from Texas tonight. Welcome, welcome. Go Cowboys. We are a Cowboys family. So welcome. K through 6 math and GK, a couple of you. Awesome. Again, plenty of problems for you tonight as well. Jamie is creating a new exhibit at her local children's museum in the circular exhibit room. The room has a diameter of 68 feet. She wants to create 6 different mini exhibits that all have equal area. To delineate each area, she will use bright, flexible baseboard along the wall that is a different color for each area. If the different colored baseboards cost $2.50 per foot, how much will it cost for each section of baseboard? Use 3.14 for pi. This is a very interesting question. Anytime that I'm doing a geometry problem, I'm going to draw a picture. So I'm going to go ahead and draw the circular exhibit room so that we can see it. So don't mind my circular drawings. Circular is not the best that I have. Oh, that actually wasn't a bad circle. So here's our circular exhibit room, and it says the room has a diameter of 68 feet. It is important that you understand the vocabulary that goes with circles. With any exam, it pretty much defines that you have to know circles. So let's just go ahead and draw a circle up here. I'm going to do it in a different color actually so we can separate what our problem is and what my notes are. So we have a circle. That was a much worse circle. That's our center. We have what's called a radius right here. And then we have what's called a diameter right there. And a diameter is also the same thing as 2 different radiuses as well. And a radius is just a line segment that goes from the center to the outside of the circle. A diameter is a line segment that goes from the outside of the circle to the outside of the circle, but it goes through the center. So that's about as far as we need to go for our GK elementary people. But for my high school, middle school people, you also have chords, which are just line segments that don't go through the center. And you also have lines that are tangent to the circle, which would be a line that just goes and touches the circle at one point. All important vocabulary. So know what vocabulary you need so that you can solve appropriate circle problems. Let's go ahead and keep reading. So I've got my circle and it says that it has a diameter of 68 feet. So if we identify our center, the diameter is 68 feet. What else do we know if our diameter is 68 feet? We also know our radius because our diameter is the same thing as 2 radiuses. So if I divide 68 by 2, I know that 34 plus 34 is 68, and those are the measurements of my radii. Again, I'm going a lot deeper in this problem than I normally would if I was just solving it, but it's important that I give you little math lessons as we continue to explore this problem together. She wants to create 6 different mini exhibits that all have equal area. So what that tells me is she wants to, and I'm going to erase that and we'll just define it out here. Those are 68 feet. What that tells me is that she wants to create 6 different areas that are mini exhibits in this circular room. So we have exhibit A, we have exhibit B, we have exhibit C, we have, and we could keep going around the circle, and they all have the same area. What else do we know? It says she's going to use bright, flexible baseboard along the wall that is a different color for each area. What does that baseboard tell us we're trying to find? Baseboard is going to be the circumference. How did I figure out that this word meant circumference? Because area of a circle is the inside of it in units squared. And circumference of a circle, we just lost connection. Let's reconnect the iPad. Sorry about that. Circumference of a circle is going to be the perimeter of that circle. So we know area is the middle and circumference is that outside piece of the circle. So circumference of the circle is like the perimeter of the circle. It just has a different name. Now, if you text this number for the slides, you will get a blank copy of the slides. So if you really want the notes, I highly encourage you to snap a picture when I'm done with each problem so that you know how to solve it. All right. If the different color baseboards cost $2.50 per foot, how much will it cost? Well, the first thing I have to do, step 1, is find the circumference of the circle. Then I can find the cost. But then it's not asking for the cost of all the baseboards. It's asking for the cost of each section. So then I'm going to have to divide by 6 because I have 1, 2, 3, 4, 5, 6 different sections. Are we following? All right, let's keep going. So could you divide by 6 before you find the cost? Yes, you absolutely could. You could divide after the circumference or you could divide after the cost. Either one is going to work. So let's go ahead and get started. Circumference of a circle. C equals 2 pi r, where r is your radius, c is your circumference. It says use 3.14 for pi. So I'm going to go ahead and do c equals 2 times 3.14 times my radius, which this was my diameter and 34 was my radius. So times 34. 34 times 2 is 68. I'm going to use a calculator. Not everybody in this room is going to get a calculator. You need to know if you get a calculator or not by looking at your test blueprint and your test outline. So 34 times 2 times 3.14 gives me 213.52. What does that measurement represent? That measurement represents the circumference of the whole circle. Don't get lost in the answer choices just because it's there. That's the circumference. That's not even the cost. Now, in order to find out how much that's going to cost, I can multiply it by $2.50. So 213.52 times $2.50 is going to be $533.80. But what does that number represent? That number represents the cost of all the baseboards in the entire circle. But it asked us for each section. So now I have to take that and divide it by 6. When I divide it by 6, I get $88.90. It looks like 0.9666667. And so when we round that to the nearest cent, it's going to be 0.97. So B is going to be our answer. But you notice that D is an answer, 533, and 35.59 is an answer. And that would be if we divided the 213 by 6, but we never found the cost. So it's critical that you know what your plan is and that you follow it. That's why I like to have some sort of plan outlined so that I know, okay, I have to find the circumference. I have to find the cost and I need to divide by 6 so I don't lose any of my steps in the process of looking at my answer choices. All right, problem 1 done. Let's move on to problem 2. A parallelogram has an area of 300 feet squared. A new parallelogram is created by dilating the original by a factor of 4. What is the area of the new parallelogram? All right, let's talk about dilations really quick. Dilation means we're expanding it. Like when you go to the eye doctor and you get your eyes dilated, they put those drops in your eyes, and what happens to your pupil? They get really big, which is why you can't look at, you have to go out with those crazy glasses and all of that. The same thing happens when we dilate a shape. So we're dilating it by a factor of 4, which means we're making it bigger, which means already I can cross off A because 75 is smaller than 300. So we're not shrinking it by a factor of 4, we're dilating it. Now, it's important that we know the area of a parallelogram so that we can kind of visualize what this is going to look like. A parallelogram, like a standard parallelogram, I guess, if you will, is going to look something like this. Now, a parallelogram by definition has 2 sets of congruent, parallel sides. That's a lot of vocabulary. Congruent means they are the same, they are equal in measurement, and parallel means they're never going to cross. 2 sets means I have 2 pairs. So this side and this side are of equal length, and they are parallel. And then this side and this side are of equal length, and they are parallel, which is why this is a parallelogram. However, what's another shape that could be classified as a parallelogram? A rectangle, a square, a rhombus, all of those are parallelograms. Because again, this side is congruent and parallel to that side, and this side is congruent and parallel to this side. Now, a rectangle is a very special kind of parallelogram because it has 90-degree angles, but it's still a parallelogram. But for the purposes of this problem, we're going to imagine that the parallelogram looks something like this. And it has an area of 300 feet squared. Now, if I didn't know what dilating means, I would go ahead and figure out some sides. So if I know that the area of a parallelogram equals base times height, where your height is going to be the actual height of your parallelogram, not the slant height. If you go to the doctor or you bring your kids to the doctor and they measure them up against a wall, they don't stand up against the wall with their feet really far away, right? They stand nice and tall. And so we measure shapes with their height by how tall they are, not how slanted they are. So what times what could give us 300? There's no wrong answer here. What times what could give us 300? 10 times 30. So this could be 10, and this could be 30, because 10 times 30 is 300. Now, you'll see why I'm doing this in a minute. If it's dilated by a factor of 4, that means that this is going to be multiplied by 4, and this is going to be multiplied by 4. So my new parallelogram is going to have side lengths of times 4 times 4. 10 times 4 is 40 as my height. 30 times 4 is 120. So this side is going to be 120. Now, if I find my area of my new shape, 120 times 40 is 4,800, which is D. Now, some of you are wondering, why is the answer not B? Because we have to remember that area is square units. So if I just multiply this number times 4, I'm not actually dilating the shape by a factor of 4, which means that I need to multiply my sides by 4. I want you to think about it this way. If I have a shape, a square, that has an area of 4, 2 times 2. If I multiply 4 times 4, which would be the area, then we're saying that the new shape should be an area of 16. But if we actually dilate the shape by a factor of 4, 2 times 4 is 8, 2 times 4 is 8, and 8 times 8 is 64. Let's take a look at what that's going to look like. If I multiply this by 4, I'm going to have 8 on this side. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to have 8 on the other side. So really, I would have to multiply the 300 by 16 because I have to take this and square it because my units are squared. So if I don't want to go through this process that I just did, and you just want like a quick and easy process, if we're dilating a shape by a factor of something, and we want the new area, we would have to square it. So if it said dilating the original by a factor of 3, what is the new area? We would have to square 3, get 9, and then multiply the original area by 9. What if we were doing volume? What do you think we would do if we were doing volume? Volume is units cubed. So if we had the volume of the original, and I'm actually going to add a page here because we're starting to get muddled on this problem. If I had the volume of my original shape equals 200 feet cubed, and I dilate that shape by a factor of 3. Because volume is units cubed, if I don't want to take my shape and somehow figure out my units, multiply those by 3, and find the new volume, what I would have to do is take this, cube it, which 3 times 3 is 9, 9 times 3 is 27, and then multiply my original volume by 27 to get the new volume, which would end up being 5,400. So if it's volume, we have to cube it. If it's area, we have to square it. Does that make sense if we're using dilations as a concept? All right, let's go ahead and keep going. This problem. Raise your hand if you were here last week when I ran out of time and I just flew through this problem. That's what happened last week. So if you were here last week, you saw me absolutely fly through this problem. I did have a question last week. Could this be on the GK? It could. Here's why. I pulled up the GK blueprint and looked up the different skills that are on the GK just to be sure. And under competency 1, it says, solve real-world problems involving the 4 operations with rational numbers. This is not one of the 4 operations, so that doesn't fit. But then under knowledge of algebraic thinking in the coordinate plane, which is competency 3, it does say solve equations. This is an equation, or inequalities graphically or algebraically. And in this case, we are solving this algebraically. And so this does have the potential to be on the GK because they did not identify what kinds of equations we're looking at. So which of the following values for x can be considered an extraneous solution to the equation above? Extraneous means not possible. Like we solve the whole problem, it works, we get multiple answers, but when we plug them back into the original problem, it doesn't work. So extraneous solutions are super weird because we solve the problem correctly, we get 2 answers or 3 answers or however many, then we plug it back in and it doesn't work. Never made sense to my brain. But let's go ahead and solve this problem. So we have the square root of x minus 1 plus 4 equals x minus 3. Now, keep in mind, our goal is to isolate the value of x so that we can solve it and find our solutions. First thing I'm going to do is subtract 4 from both sides. So I get 4 minus 4 is 0. Why did I do that? So that I can start to isolate that x. And whatever I do to one side of the equation, I've got to do to the other. So I have the square root of x minus 1 equals x minus 7 because negative 3 minus 4 is 7. Again, if I do anything in these problems where you're like, whoa, I need you to explain why negative 3 minus 4 is negative 7 or anything like that, feel free to comment so that I can explain it further, okay? Because there are certain things that I'm assuming people know, but because we would literally run out of time every week if I explained everything. But if you need me to explain something, I need to know. So just let me know in the comments. All right, moving on. Now, here's the problem. We've got x that's stuck inside of x jail. It's stuck inside of radical jail. I can't get rid of that, or I can't get it over here with this x unless I undo the radical. So we know the opposite of addition is subtraction. So addition and subtraction undo each other. We know multiplication and division undo each other. A square root and a square or an exponent undo each other. Or if we had a cube root, a cube would undo that radical. So in this case, I'm going to square both sides so that I can unlock this x from radical jail and get it with the other x. So what happens is these cancel out and I'm left with x minus 1 equals x minus 7 squared. Please do not make the mistake of distributing that square symbol. So many people make the mistake of doing this. X minus 7 squared equals x squared minus 49 or plus 49, depending on which way they interpret that. That does not equal. Because if we think about what an exponent means I'm going to do that thing that many times. So this square means I'm going to multiply this 2 times. So what it actually looks like is x minus 7 times x minus 7. Now what am I going to do? Some of you know it as FOIL, first, outer, inner, last. Some of you just know it as the distributive property. I'm literally just going to distribute the x through, and then I'm going to distribute the negative 7 through. So x times x is x squared. X times negative 7 is minus 7x. Negative 7 times x is minus 7x. And negative 7 times negative 7 is positive 49. Now, I know that I can combine just these. I cannot combine x squared with x with constants because they are not like terms. But I can do the negative 7 and the negative 7. So I'm going to go ahead and just simplify that piece of it. And I know it's negative 14x. All right, Now I can get this x and this -1 over to the other side with all of the other terms. So if I subtract, or if I add 1 to both sides and I subtract x from both sides, I get 0 equals x squared minus 15x plus 50. Now, you're wondering, why did I do that? Because the x's are not by themselves now. The x's are with that positive 50, and that doesn't make sense. For those of you who have quadratic understanding, you know exactly why I did that. For those of you who have limited quadratic understanding, this is a quadratic function. I know that because there's a squared, which means there's going to be a potential or a maximum of 2 solutions. A quadratic has the potential to cross the x-axis 2 times. That's what every quadratic looks like. It's just a matter of where it is and how big or skinny it is and if it's upside down or right side up. It could float up here and not cross at all. It could come down, bounce, and come back up and only cross 1 time. It could be upside down here and not cross at all as well. There's a lot of different possibilities, but with a squared, we know it has the potential to cross 2 times. So I need to solve it like a quadratic equation. Now, if you are not familiar with solving quadratic equations for solutions, I highly recommend that you either join one of our boot camps or you watch a Khan Academy video or something about factoring and quadratic formula and all of that, because that could literally be a 2-hour lesson and we don't have that much time. So I'm going to factor this because I know it's factorable. How do I know it's factorable? Because these solutions, extraneous or not, are all clean rational numbers. So I'm going to go ahead and figure out what times what gives me this. What times what gives me x squared? X times x. That's my first term. X times x gives me x squared. What times what is going to add or multiply to give me 50, but add to give me -15? 10 and 5. -10 times -5 is positive 50. Again, if that transition right there was confusing, I highly recommend you reach out to me on Facebook. You join one of our boot camps so that you can really understand how to solve quadratic equations. I'm going to set them both equal to 0. Because if this piece equals 0, the whole thing is going to equal 0 and it will satisfy this equation. If this whole thing equals 0, 0 times anything is 0 as well. So x minus 5 equals 0, x minus 10 equals 0. X equals positive 5 because I'm going to add 5 to both sides. X equals positive 10 because I'm going to add 10 to both sides. Now you see where our dilemma is. The answer is not 2 or 17 because neither of those are solutions for our equation. But we did get 2 solutions. We got 5 and we got 10. What am I going to do now to figure out which one is extraneous? Now I need to plug it back into my original formula. So I'm going to do x equals 5 right here. I have the square root of 5 minus 1 plus 4 equals 5 minus 3. Square root of 4 plus 4 equals 5 minus 3 is 2. The square root of 4 is 2. 2 plus 4 equals 2. 6 does not equal 2. So this right here is extraneous. Let's go ahead and do x equals 10. Square root of 10 minus 1 plus 4 equals 10 minus 3. Square root of 10 minus 1 is the square root of 9 plus 4 equals 10 minus 3. Square root of 9 is 3 plus 4 equals 10 minus 3. 3 plus 4 is 7. 10 minus 3 is 7. Ding, 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 ding. We have a winner as our solution. But it's important that you note they asked us for the extraneous solution, which is the one that doesn't work, which is actually x equals 5. Tricky, tricky. All right, that was a lot of information, mainly for our... There's my dog. That's Pudge. I think my husband just had pizza delivered, which is why he's freaking out. All right, that was mainly for my GK core, middle school, high school math people. K through 6 math people, what I need you to understand is just basic understanding of equations. Let's go ahead and go into our next problem. I apologize for all of the barking. What is the 14th term in this sequence of numbers? I promise I'll start barking in like 2 seconds. What is the 14th term in this sequence of numbers? 196,608, negative 49,152, 12,288, ... What is the 14th term? And now that the pizza's in the house, he is good to go. So we need to be able to figure out, is this an arithmetic or a geometric sequence? Now, it's important that we understand the difference between those. An arithmetic sequence is one that has a common difference. A common difference is something that is being added or subtracted between the terms, to get us from one term to another. A geometric sequence has a common ratio, and it has something that's being multiplied or divided in between the terms to get us from one term to another. So, how do I get from 196,608,000 to negative 49,152 to positive 12,288? The first thing I immediately think of is this is probably geometric. Why? Because if I'm flip-flopping between negative and positive, it means I'm probably multiplying by a negative value. So if I multiply this by a negative, I'm going to get a negative. And then if I multiply that by a negative times a negative is a positive. Keep in mind, for an arithmetic and a geometric sequence, we have to add and subtract the same thing, hence common. And with a geometric, we have to multiply and divide the same thing, hence common. So if it's a geometric sequence, I'm multiplying by a negative, I'm multiplying by that negative every single time. Does that make sense? So I've already ruled out arithmetic. But if it's geometric, what could it be? What could I be multiplying or dividing by to get from 196 to 608? Or 196, 608 to 49,152. So I'm just going to play around with some numbers. 196, 608. And I'm going to divide that by this number right here, 49,152. And I get the number 4. So let's test that. If I divide 196 by negative 4, and then I divide this by negative 4, would it be consistent? Let's go ahead and find out. 196, 608 divided by negative 4. Indeed, I get negative 49,152. Now, this was a problem I did pull and I adjusted and changed from a 6 through 12 mathematics. However, pre-K through 3, K through 6 people, you have to understand patterns of numbers. You have to understand common ratios and common differences. It just may not be to this scale that we see this problem. But you still have to be able to identify patterns is what they call it. I'll give you an example here in a minute. Now, if you have a calculator because you're a middle school or high school prep person, rather than sitting here and then clicking divided by negative 4, divided by negative 4, if you just keep hitting the equal button, so I'm going to do 196, 608 divided by negative 4, and you just keep hitting this equal button, it'll just keep giving you more and more and more and more and more and more answers How cool is that? So you don't have to keep pushing divide by -4. So we're looking for the 14th term. Let's go ahead and rule out some of these answers already. So 1, 2, 3, 4, 5, 6, 7, 8. I did not do that with enough space. Let's do it a little smaller. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. If the first term is positive, that means the second term is negative. That means the third term is positive. Negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. The 14th term has to be negative, which means A and B are automatically out. So if you're running out of time and you don't have enough time to solve this problem, that was 10 seconds right there. Now you can just take a guess. All right. So now that I know that, how did I know that? Because a negative times a positive is a negative. And then a negative times a negative is a positive. And then a positive times a negative is a negative, and it keeps going. But let's go ahead and do this in our calculator. 608 divided by -4, 2, 3, 4. This is my 4th term, 5th term, 6th term, 7th term, 8th term, 9th term, 10th term, 11th term, 12th term, 4, 6, 8, 7, 5, 13th term, 14th term. So I know that my fraction needs to equal -0.002929969. Now you're like, I don't know what that is. Well, because you just used your calculator, you can totally just divide -3 divided by 1024 in your calculator. And you can do -3 divided by 4096 in your calculator and just get the decimal. So 3 divided by 1024 indeed gives me 0.002929. 3 divided by 4096 gives me 0.00073, which I'm assuming is the 15th term. So that's how you solve sequences, K through 6, pre-K through 3. You likely might get a problem that looks something like this. What is the pattern? And in this case, it's an arithmetic sequence. The common difference is a +4. So you just have to be able to look at that series of numbers and determine that I'm adding 4 to each term, which is just an arithmetic sequence in middle school and high school, but we're really just training our kids to look for those patterns in numbers, and the answer would be something like add 4 to each term. So while this specific problem was a middle school, high school problem, it benefits all of us to truly understand that patterning. All right, let's look at problem number 5. We are definitely not getting through 10 problems tonight. Expand the following expression, 2x minus 3y cubed. Now, here's what I need us to understand. I need us to understand that this is not a distributive property with exponents. You cannot just take this, distribute it, and call it a day. 2x minus 3y cubed does not equal 8x cubed minus 9y cubed. That is not how this works. Remember, when we're looking at an exponent, it means do that whole thing that many times. So what I'm actually doing is 2x minus 3y times 2x minus 3y times 2x minus 3y. So I'm going to go ahead and use the distributive property now to distribute my 2. And I'm only going to look at these first 2 binomials for now. So I'm going to go ahead and distribute that. 2x times 2x is 4x squared. 2x times negative 3y is negative 6xy. Now I'm going to distribute this. Negative 6xy plus 9y squared. So this simplifies because I can combine these terms because they are like terms. This simplifies to 4x squared minus 12xy plus 9y squared, all times 2x minus 3y. All right, let's keep going. I'm going to use the distributive property again. So now I'm going to distribute this 4x squared all the way through. Then I'm going to distribute the negative 12xy all the way through. Then I'm going to distribute the 9y squared all the way through. So let's go ahead and do that one step at a time. 4x squared times 2x. 4 times 2 is 8. X squared times x is x cubed. Now I'm going to multiply it times that. Minus 12x squared y. Now it's time for the negative 12's turn. Negative 12 times 2 is negative 24x squared y plus 36xy squared plus 18xy squared minus 27y cubed. Now, I'm going to go ahead and look at this expansion and see if there's anything that I can simplify. So, there's no other x cubes. X squared y can be combined. And xy squared can be combined because those have the same variables. So, I have 8x cubed. Negative 12 minus 24 is negative 36x squared y. And 36 plus 18 is a positive 54xy squared minus 27y cubed. So it looks like our answer is C. Now, pretty much everybody should understand that basic understanding. Keone is one step ahead of me. Why not use the Pascal triangle? I did it this way first because I wanted to be able to show how to distribute, how to do basic algebra, and Pascal's triangle or the binomial expansion theorem is very isolated to a high school, oh, there's the dog, a high school exam. So for my GK people, my elementary people, you need to understand basic algebra, basic distributive property. And sometimes we just don't remember the binomial expansion theorem or Pascal's triangle. But Pascal's triangle would definitely be easier and more direct if you remember that theorem in your head. So the binomial expansion theorem says this. I'm going to make a new page for the binomial expansion theorem. This really comes in handy when they want you to expand something like 2x minus 3y to the 8th power. Ain't nobody has time for that. So, and if they gave you a problem like that, they might say, what is the third term in this sequence? The binomial expansion theorem looks something like this. 1, 1a, 1b, 1a squared, 3a squared b, 3ab squared, 1b. Nope, I skipped a level. 1a squared, 2ab, 1b squared. And then from here, so like once you get these first 3 layers, you're always going to have a 1 on the outside and a 1 on the outside. But then from there, you add like the 2 layers up top. So 1 plus 2 is 3. And then you multiply those variables. So a squared, I don't like that color. And let's go a little bigger. A squared times b would be a squared, no. And then this would be 3ab squared. And then we do it again, 1a to the fourth, 1b to the fourth, and then we would add these together. So 4, 3 plus 3 is 6, 4. And then we could do it again, 1a to the fifth, 1b to the fifth, and we could add these 5, 10, 10, 5. So this is the idea of what Pascal's triangle looks like. Now, when you look at this, this is the value of A and this is the value of B. So if it said, like, what is the sixth term? In this case, the third term, let's go to the third term. The third term would be 10, but then we would have to multiply that 10 times the A and the B. So if you don't understand that, that's okay, unless you're taking high school math and then you need to understand that. But if you can remember, it starts with 1, 1, 1, 1, 2, 1, and then you add those coefficients together to get your triangle. That's really the foundation of the binomial theorem or Pascal's triangle. So Keone was on to something, but because this was just cubed, it's possible to go ahead and expand that. It's just definitely easier to use the binomial expansion theorem. All right, let's keep going. Hey, Hope, no worries that you're late. You can continue to watch this even after we are done. So we have time for literally one more problem. We have gotten through 5 problems today, and that is A-okay. Let's go ahead and do this problem right here. Mrs. Lindstrom gave a biology test. The scores of the students are shown below, with the exception of one student who was absent. So we've got all of the biology scores, but then we have a kid that was absent. If Mrs. Lindstrom wants to have a class average of 80 on the exam, what does the absent student need to score on the test? Round to the nearest whole number. So it's important we understand how to find average in order to be able to find this. This is going to be perfect for anybody in this room. So we know that average and mean are the same thing. And the way we solve it is we add all of our data points up, so sum of data, and then we divide it by the number of data points that we have. So I could add all of these up, and I could divide by, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. I could divide by 9, and I could get the average. But we have a student that's absent. And we want to know what that student needs to score to have a class average of 80. So if I divide this by 10, because ultimately I'm going to have 10 scores, and I equal it to my class average that I want, I can just solve for X. Now, I'm going to go ahead and add 87 plus 62 plus 77, plus 94, plus 73, plus 81, plus 88, plus 76, plus 72. I do not have a calculator that works because my phone just died. So I'm going to go ahead and do this by hand. So 7 plus 7 is 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. 8 plus 4 is 12. 12 plus 6 is 18, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61. 64, 65, 66, 71. All right, 710. As you can tell, mental math is not my strength. So we have 710 plus X divided by 10 equals 80. Now, I need to unlock the X from numerator jail. So I'm going to multiply both sides by 10 to undo that division. And I get 710 plus X equals 80 times 10 is 800. Now I just subtract 710 from both sides, and I get X equals 90. So that student needs to score a 90 on that exam. All right. So, unfortunately, we did not get through all of our problems. We are going to do a data focus. So, we're going to focus on data, probability, and statistics the next time we meet on Wednesday. So, because we've done a geometry focus and we've done an algebraic thinking focus, and I really think that doing a data and statistics and probability focus is going to be really beneficial for us. So, that's what we're going to focus on next time. We will finish the problems we didn't finish today on that session. So, stay tuned because Dr. A does have a special message for all of you. Thank you so much for joining me tonight, and I look forward to seeing you next week. So, Dr. A, are you there?
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.